In this episode, we start looking at the resources security teams monitor and why log aggregation becomes such an important foundation for detection, investigation, and reporting. When you first hear the word monitoring, it can sound like someone is simply watching screens and waiting for something bad to happen. Real security monitoring is broader than that. It means collecting signals from many parts of an environment so you can understand what is normal, what has changed, and what might need attention. Those signals may come from servers, laptops, cloud services, applications, network devices, identity systems, and security tools. Each resource gives you a different view of activity. When those views are brought together, a security team can see patterns that would be hard to notice from one system alone. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A system is any computing resource that performs work for the organization, and that can include servers, workstations, virtual machines, cloud instances, and specialized appliances. Security teams monitor systems because systems show signs of both normal business activity and possible compromise. A server might show repeated failed login attempts, unusual process activity, unexpected restarts, or changes to important files. A workstation might show a new application starting unexpectedly, a user logging in at an unusual time, or a connection to a suspicious external address. None of those signs automatically proves that an attack is happening, but each one can become part of a bigger picture. Systems matter because attackers often need to use them, change them, or move through them to reach the data or access they want. Applications are another major monitoring target because they are often where people interact directly with business processes and data. An application might be a customer portal, a payroll system, an inventory platform, a learning system, or an internal request tool. Application logs can show who signed in, what actions were taken, what errors occurred, and whether the application behaved in an unusual way. They can also reveal problems that a network device would never understand, such as failed payment attempts, unexpected permission errors, or repeated requests for records that a user does not normally access. Applications are important because they understand context. A firewall may know that traffic reached a web server, but the application may know that someone tried to reset an administrator password or view sensitive records. Infrastructure refers to the supporting technology that keeps the environment running. This includes network devices, storage systems, virtualization platforms, cloud infrastructure, directory services, and other shared services. You may not interact with these resources every day as a normal user, but the organization depends on them constantly. Monitoring infrastructure helps security teams notice changes that could affect availability, confidentiality, or integrity. A switch might show unusual traffic patterns. A storage platform might show unexpected access to large amounts of data. A directory service might show a privileged group membership change. A virtualization platform might show a new virtual server created without approval. Infrastructure monitoring matters because attackers do not always go straight for a single laptop or application. They often look for the underlying systems that let them control more of the environment. Cloud services add another layer to monitoring because many organizations now run important systems outside traditional data centers. Cloud environments may include hosted servers, managed databases, storage buckets, identity services, serverless functions, and software platforms delivered over the internet. Monitoring cloud services requires attention to configuration changes, access activity, administrative actions, data movement, and service usage. A small change in a cloud permission can expose data more broadly than intended. A new access key may allow a workload to connect to other services. A storage location may become reachable from the public internet if it is misconfigured. Cloud monitoring also matters because resources can appear and disappear quickly. If the organization cannot see those changes, it may lose track of what exists and who can access it. Endpoints deserve special attention because they sit close to the people using the environment. An endpoint can be a laptop, desktop, tablet, phone, or other user-facing device. These devices are common targets because people open email, browse websites, download files, join meetings, and use business applications from them. Monitoring endpoints can reveal suspicious processes, unusual file behavior, malware detections, device health problems, removable media use, and connections to unexpected destinations. Endpoints also help tell the human side of an event. A strange login might make more sense if it happened right after a phishing email was opened. A suspicious file transfer might be more concerning if it came from a device that also showed signs of credential theft. Endpoint visibility helps connect user activity, device activity, and security risk. Network devices are monitored because they show how systems communicate. Routers, switches, firewalls, wireless controllers, load balancers, and other network components help move traffic through the environment. Their logs and traffic data can show blocked connections, allowed connections, unusual destinations, traffic spikes, scanning behavior, and policy violations. A firewall might show repeated attempts to reach a closed service. A wireless controller might show a new device joining from an unexpected location. A router might show traffic moving in a pattern that does not match normal business use. Network monitoring does not always reveal what a person did inside an application, but it can show where traffic went and whether the communication pattern makes sense. This is especially useful when teams are trying to understand the path of an attack. Identity systems are also central to monitoring because modern security depends heavily on knowing who is accessing what. An identity platform may record sign-ins, password changes, group membership changes, multi-factor challenges, access denials, and administrative actions. Multi-factor authentication, MFA, logs can show whether someone successfully completed an additional verification step or whether repeated prompts were sent. Identity logs help security teams spot patterns such as impossible travel, repeated failed attempts, sign-ins from unusual devices, or access from locations that do not match the user's normal behavior. Attackers often want valid credentials because using a real account can look less suspicious than exploiting a technical flaw. Monitoring identity activity helps the organization notice when a normal account may no longer be under normal control. Log aggregation is the process of collecting logs from many different resources and bringing them into a central place where they can be searched, compared, analyzed, and retained. A log is a record of something that happened, such as a login attempt, file access, application error, network connection, configuration change, or security alert. One log source can be useful, but many log sources together are much more powerful. If a user account signs in from an unusual location, then accesses a cloud storage location, then downloads many files, those events may appear in different systems. Log aggregation helps bring those pieces together. Without aggregation, a security team may have to check each system separately, which slows the response and increases the chance that important details will be missed. Good log aggregation depends on collecting the right data, but it also depends on time, consistency, and context. Timestamps matter because security investigations often rely on the order of events. If one system records time incorrectly, the story can become confusing. Consistent naming also matters. The same user might appear as an email address in one log, a username in another, and an identification number in a third. Context helps a team understand what a resource is, who owns it, and how important it is. A failed login against a forgotten test server may be less urgent than the same activity against a payment system. Aggregation is not just about dumping information into one place. It is about making that information usable when someone needs to understand what happened. Detection depends on monitoring because you cannot reliably detect what you cannot see. A security team creates rules, alerts, or analytics that look for activity associated with risk. That might include repeated failed logins, suspicious administrative changes, unexpected outbound traffic, malware detections, or access to sensitive files at unusual times. Detection is stronger when it can compare events across different resources. A single failed login may not matter. A failed login followed by a successful login from a new location, followed by a privilege change, followed by data access, tells a different story. Monitoring turns isolated events into signals. Aggregation helps those signals meet each other. The more complete the visibility, the better the chance that real threats are noticed early enough to reduce harm. Investigation also depends on monitoring because once an alert appears, the team needs evidence. An alert is a starting point, not the full answer. Security teams ask questions such as when the activity began, what account was involved, what systems were touched, what data may have been accessed, and whether the activity is still happening. Logs from systems, applications, infrastructure, cloud services, endpoints, and network devices can all help answer those questions. The team may start with one alert and then follow the trail across many resources. This is why centralized logs are so valuable. They let the team search across time and across systems without relying only on memory, screenshots, or whatever happens to still be available on one device. Reporting is another reason monitoring matters. Security teams need to explain trends, incidents, control performance, and operational workload to people who may not read raw logs. Reporting can show how many alerts were handled, which systems generate the most suspicious activity, whether patching reduced certain findings, or whether access problems are increasing. Reports may support management decisions, audit needs, compliance obligations, and lessons learned after an incident. Good reporting depends on trustworthy data. If logs are incomplete or scattered, the report may tell only part of the story. When logs are aggregated and organized, the team can produce clearer summaries. The goal is not to overwhelm leaders with technical noise. The goal is to turn monitoring data into understandable information that supports better decisions. A common misunderstanding is that monitoring means collecting everything forever. In real environments, that is usually not practical. Logs take storage, processing power, money, and staff time. Some logs are highly valuable, while others may be noisy or rarely useful. Security teams need to decide what to collect, how long to keep it, how to protect it, and how to search it efficiently. Another misunderstanding is that logging alone creates security. Logs do not help much if nobody reviews them, alerts on them, protects them from tampering, or uses them during investigations. Monitoring is a living process. It needs tuning, ownership, and review. As systems change, applications move, cloud services expand, and business processes shift, monitoring must change with them. The main takeaway is that monitoring gives a security team the visibility needed to notice problems, investigate events, and explain what happened. Systems show activity on servers and devices. Applications show user actions and business context. Infrastructure shows changes in the shared technology that keeps everything running. Cloud services show activity in environments that may change quickly. Endpoints show what is happening close to users. Network devices show communication patterns. Identity systems show who is trying to access resources and how that access is being used. Log aggregation brings those signals together so the organization is not forced to search one resource at a time during a stressful event. When monitoring is planned well, it becomes the foundation for better detection, faster investigation, clearer reporting, and stronger security decisions.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.